Computer networks data link layer. We can consider the data link layer has two sublayers. The upper sublayer is responsible for data link control and the lower sublayer is responsible for resolving access to the shared media. If the channel is dedicated, we do not need the lower sublayer. Figure 12.1 that shows these two sublayers in the data link layer. Data link layer divided into two functionality oriented sublayers. Data link layer which has the two sublayer. First one is the data link control and the second one is the multiple access resolution. The IEEE has a functionality that actually made this division for local area networks. The upper sublayer that is responsible for flow and error control is called the logical link control layer, that is LLC layer. The lower sublayer that is mostly responsible for multiple access resolution is called the MAC layer, that is media access control layer. When nodes or stations are connected and use a common link, that is called a multi-point or broadcast link. We need a multiple access protocol to coordinate access to the link. The problem of controlling the access to the medium, which is similar to the rules of speaking in an assembly. The procedures guarantee that the right to speak is upheld and ensure that two people that do not speak at the same time, they do not interrupt each other, also they do not monopolize the discussion and so on. The situation is similar for multi-point networks. Many formal protocols that have been devised to handle access to share a link. We categorize them into the three groups. Figure that is shown the protocols belonging to the layer. This is the figure that is the taxonomy of multiple access protocol discussed in this chapter. Multiple access protocols categorized into three ways. First one is the random access protocol, second one is the controlled access protocol, third one is the channelization protocols. In random access protocol, which has the Aloha, CSMA, CSMA, CD, CSMA, CA. In controlled access protocol, which has the reservation, polling, token passing. In channelization protocols, which has the FDMA, TDMA, CDMA. Random access. In a random access or contention methods, there is no station is superior to another station and none is assigned the control over another. No station permits or that does not permit another station to send. Two features give this method its name. First one is the there is no scheduled time for a station to transmit. Transmission is random among the stations. That's why these methods are called a random access. In the second feature, there is no rules which is specified which station that should send next. Stations compete with one another to access the medium. That is why these methods are called contention methods. To avoid access conflict or to solve it when it happens, each station that follows a procedure that answers the following questions. The questions are: first one, when can the station access the medium? Second question, what can the station do if the medium is busy? Third question, how can the station determine the success or failure of the transmission? Fourth one, what can the station do if there is an access conflict? The random access methods we study in this chapter that have evolved from a very interesting protocol that is known as Aloha, which used a very simple procedure called multiple access, that is nothing but MA. The method was improved with the addition of a procedure that forces the station to sense the medium before transmitting. This was called carrier sense multiple access, CSMA. This method that is laterly evolved into two parallel methods, carrier sense multiple access with collision detection and carrier sense multiple access with collision avoidance. In CSMACD tells the station what to do when a collision is detected. In CSMACA that tries to avoid the collision. Aloha. Aloha, the earliest random access method which was developed at the University of Hawaii in the early 1970s. It was designed for a radio local area network, that is wireless, but it can be used on any shared medium. Pure Aloha. The original Aloha protocol is called Pure Aloha. This is a simple but elegant protocol. The idea is that each station sends a frame whenever it has a frame to send. However, since there is only one channel to share, there is a possibility of collision between frames from different stations. This is a frames in a pure Aloha network. Station 1, station 2, station 3, station 4, which has the lots of frame. This one is the collision duration and this one is also a collision duration. This is the procedure for a pure Aloha protocol. Start, K is equal to 0, next send the frame and wait for